Okay. I think we're up. I think we're online. Possibly. Let's see. Okay. It looks like we are online. Nice. Okay. Today, we are going to be continuing the... What is it? Okay. We're going to be continuing the Netflix Party clone. We found out that it's not WebSockets last time. It's actually real-time polling. It's not even long-term polling, I think. It's just or long polling. It's just normal poll, which is not super great. So we either are going to continue working on that and use polling, or we're going to use WebSockets. Ideally, we would want to use WebSockets, but I want to get it work first before I consider using anything else. We're either going to work on this, or we're going to make a game. One or the other. Let's show you what I have so far. Also, let me know if you guys are interested in Minecraft modding. I feel like that's kind of cool. Okay, so projects, CD. Okay, so we have the actual Watch With Me extension, and this is what it looks like right now. We have pretty much nothing, so we're not really losing much time. The other option is what is it? Yeah, we work on Multi-Blast. This is like a video game that I was making. I can just show you a little bit of what it looks like. So we can just cd into tilde, see that. Git clone. Oh gosh. Okay. cd into Multi-Blast. Not you. And then we're gonna go. We need something to run the server itself, and I think that is in cd into 19 ls cd web ls. Okay. Okay, I think we need cd into dist. So we're gonna cd into game web dist clear source. Yeah. So after we're in dist, now we can do live server. I wonder if this will work. I have not found live server. Oh, I need to install it. There we go. So this is what it looks like right now. It's really simple, which is good because we have basic movement and everything, and I think this is a great platform to start working on WebSockets. And just seeing if we can get 2 players in this game. Let's change the name of this. Okay. Let's also share this. So let's go here. Let's go to announcements. Okay. I want to rename this, make it more have more personality. Multiplayer pew pew. There we go. That has way more personality. Then we can just share this updated link. Edit message. Okay, looks like it didn't change, which is fine. Okay, so our server is running on port 8080, which we have here. Let's take a look at this code. It's been a while since I worked on this. So I think we're taking a great amount of information from nobody's hiring. And I think I watched this video, and this guy was he built a game, and that's where this came from. This idea came from Kodistan. Huge shout out to Kodistan. He gave me the idea for all of this. This is the official game. I don't know if it'll let me run it. Oh, it does. So how this works is this uses... Actually, let's find out. How long is this video? 40 minutes? Let's find out what he used, because we are using the same technologies as this.
Programming adjacent age of later, which led me to the misadventure known as the software job hunt in year 2024. So to prove some basic computer literacy and add yet another non-consequential project to my resume, I embarked on a quest to make a multiplayer browser game. By the way, the game is already available, source code up to the end of this video too, so check it out if you want, or stay to watch how I made it. So the basic idea is one-on-one turn-based tactics game played on a 2D grid where players move their tanks around the board and try to shoot the opponent. Instead of squares, I'm going to use the clearly superior hexagonal grid, and I want to limit players' field of view to some radius around their vehicles to add a level of uncertainty. The map will also shrink as the game progresses to prevent players from stalling. About the graphics for the game, I decided to go with the pixelated isometric aesthetics. I like this style, and some time ago I made a simple 3D renderer and some low-poly desert theme models, which I then used to generate sprites for the game. If you don't know what sprites are, they are a series of images that you can alternate to create an illusion of movement. The client side of the game will work in the language of the browser.
Okay, so I want to make sure that we have our sprites and everything ready. So I think they're all in the assets. I found this sprite pack online somewhere. I don't know. Yeah, so this is our player. What else do we have? I think we'd probably need to open this in VS Code. Yeah. It looks like we also have sounds. Fonts, music. Okay. So right now, let's just try to get multiplayer working. I think we would need a... He did his backend in Go, which I like. So let's do that. Let's see what technology he used for the backend specifically, and we can start working on that.
Browser, JavaScript, but because I don't want to succumb to a vast pile of reference errors, I'm going to write it in TypeScript. For that, I will use the Canvas HTML element, which provides an API to draw shapes, text, images, or even 3D scenes onto the screen. And for the server side, I'm going to use the Google's Gopher link. I'm not going to use any frameworks or game engines because I'm doing it more for the process of doing than anything, but I'm going to use Gorilla WebSocket library, which at the moment is the de facto standard WebSocket implementation.
Okay, so we have two options. We can either do our backend in Go or TypeScript. If we do it in TypeScript, I think we'd use Socket.io. Otherwise, we would use whatever he said, Gorilla WebSocket. Let's learn more about that before we go any further. And the other one he said was Socket, or that I know is Socket.io. Go packages. I don't know which one is more ideal. Go is kind of nice, so I think we'll go with Go because I've never used it before. I think it'd be kind of fun. Maybe I should. Maybe I should. There we go. This has so much personality. Okay. So we can get rid of this, and we'll use this. Let's give a good overview of what this is. Chat example, that's interesting. This application shows how to use the WebSocket package to implement a simple web chat application. The example requires a working Go. Let's make sure we have Go installed. Okay, so we need to install that. How to install the development environment, which I guess we need to learn how to do as well. So let's do this first, get some idea of what WebSockets are, and then we'll go into here. Once you have Go up and running, you can download, build, and run the example using the following commands. So we're getting the actual package or the example. List F, so listing the directory. No, we're cding into something. And then we're to run all the Go files. Okay. The server application defines two types, client and hub. The server creates an instance of the client type for each WebSocket connection. A client acts as an intermediary between the WebSocket connection and the single... Hold on. A client acts as an intermediary between the WebSocket connection and a single instance of the hub type. I need to draw this out. What is it called? Like ScallyDraw. So we have client and hub. Client for each WebSocket. And a client is in between the WebSocket and the hub type. So there's hub, client, and then WebSocket. So there's hub, client, oh god, there, client, WebSocket. It says that application runs one Go routine for the hub and two routines for each client. One Go routine for the hub, two for each client. I'm a little confused on that. The Go routine communicates with each other using channels. The hub has channels for the hub has channels for registering clients, unregistering clients, and broadcasting messages. So channels are how we communicate with Go routines. So there are channels within this, and okay, so we have channels within this. Okay, channels. So we have another routine. We're going to use another channel. This is how my brain works. The hub has channels for registering clients. So that's the Go routine, right? Hub has channels. No, channels. Okay, is registering client a channel or is it a Go routine? What is a Go routine? Go routine. A Go routine is a lightweight thread of execution managed by the Go runtime, enabling concurrent programming within the Go language. Unlike traditional operating system threads, Go routines are extremely lightweight, only a few kilobytes, grow and shrink as needed, far cheaper. Okay. Okay, so it's running multiple functions at once. Yeah. So that's what a Go routine is. We have channels for each routine. A client has a buffered channel, outbound messages. One of the client's Go routine reads messages from the channel, writes messages to the WebSocket. The other client Go routine reads messages from the WebSocket, sends them to the hub. Okay, so two channels. Hold on. One of the client's Go routines reads messages from the channel, writes the message to the WebSocket. the other client routine. Yeah, we have two routines for each client. So we have two routines for each client. The other routine is the other way. The other client routine reads message from the WebSocket and sends to the hub. Okay, got it. The code used for the hub type is in hub.go. The application's main function starts the hub routine. Hub's run method is a go routine. Client sends requests to the hub using register, unregistered, and broadcast channels. To the hub using register, unregistered, broadcast channel. Okay. The hub register clients by adding client pointer as a key in the client's map. What? The map value is always true. The unregistered code is a little bit more complicated. So hub.go, client.go, what else? Hub, client, main.go. And the front end is in home.html. Okay, let's see what hub.go looks like. See if clients are registered, true or false. Messages from clients. Unregister, register. What is chan? Channel? Maybe that's what it is. Yeah, because it said the client had register, unregistered, and let's see. Client sends requests to the hub using these channels. Okay. There's like a hair in my eye. Okay, I got a good idea. I have a good idea what this is. Don't really understand fully what it means, and so this is the structure for the hub. Creating a new hub makes these. We're running. We're seeing if the client is. We're setting the client to less than h.register. In the case that client is equal to, or is it less than or equal to? Oh, maybe it's if the client wants to register. If the client wants to register, then h.client's client true. Okay. Because we're creating a new hub. Okay, yeah, that's the hub. Hub.register. In the case that the client oh yeah, if we want to unregister, this is what we're doing. If you want to message, got it. Then we broadcast. And that's what this is. Okay. That's hub. Then we have client. This looks kind of long. Okay. The code for client type is in client.go. The serve WebSocket function registered by the application's main function is the HTTP handler. Okay. Wow, that's really basic. The handler upgrades the HTTP connection to the WebSocket protocol, so that's in client.go. So it's serve.ws. Yeah, because how it works normally, right, is we have a normal connection and we need to upgrade that to WebSocket, so it wouldn't be HTTP, it'd just be WS, I believe. Client middleman between WebSocket connection and the hub. That's what we have here, right? Yep. Okay, actually, I'm liking this project a lot more. Huge, thanks, welcome, Inex. Let's see, that was a big yawn, oh my gosh. Okay, so client is limited to the WebSocket connection to the hub. Read pump pumps message from the WebSocket connection to the hub. Application runs read pump in the per connection go routine. We ensure that there's one reader on a connection. Okay, so we make sure there's at least one person. Maybe I should have chat open. Maybe I should have chat open. Let's go here. Okay, there, it's easier to read now. Per connection will run read pump. Yeah, and make sure there's at least one connection. Okay, not fully understanding this syntax. Maybe this pointer. I'm not really understanding that, but you'll get into those details later. There's read pump, there's write pump. Write pump pumps messages from the hub to the WebSocket connection. Okay, read pump pumps messages from the WebSocket connection to the hub. So this is read. So it's read. Oh my gosh, what is this? This is for client, right? Yeah. So if we're going from WebSocket to hub, we're going to do read pump. WebSocket to hub, we're going to use read. Otherwise, we're going to use write. My handwriting is glorious. We're going to use write. A go routine running write pump is started for each connection. For write pump started for each connection. The application ensures there's one writer. Excuse me. For each connection. Okay, that makes sense. Okay, and then serve WS handles WebSocket connections from the peer, WebSockets requests from the peer. Okay, so we're going to upgrade the HTTP response writer. We're passing in the response writer, the request, and nil. Okay. If the error is non-null, then print the error and return client equal to set hub to hub connection send to make this. Okay, this is a little confusing. I think I'll figure it out. Okay, so we have a general idea of how this WebSocket works. So I'm assuming that'll translate over to other WebSocket routines. So yeah, if we're using Gorilla WebSockets, we would not use a China. Oh wow, we should just open this. Client server model. Okay. Wow, this is horrible. No, nothing. So maybe this is the backend for front end. This is the actual backend. So here we're upgrading the connection to a WebSocket connection. Don't know what this is about. Okay. That's a bit tricky. So there's beautiful documentation on this. Oh, did we install Go? Yeah, we did. Let's make sure that this is running, or let's set it up for Linux, for Moon, and oh, let's make sure it's running Go version. Nice. Getting started tutorial. Yeah, and that's what we need to do. Create a module. Okay, so we'll do a nice cd clear. What is it? We're in web right now. We want to go into, let's hide this. Well, there's source. Where did he structure it? There's web distance source, and where web is, that's where, in that same place we're doing the inits. Okay. So now we can do go mod init, and we'll call it multi blast. And then okay. That's should have been the same. No, it should be on the same line as web. So it should be. So we should be actually in 19 game. So we need to go to ls rm rf go.mod. Maybe we should have moved it instead. ls cd. Now we can do the. There we go. That's nice. Okay. We have module multiblast, and then we see a sum. Let's do a go mod tidy. Go mod tidy. And we don't have any packages, so that's fine. But if we go into here, let's just do that 1.5.3. What is this one? Yeah. Okay. There we go. Okay, that's nice. Go mod, go sum. So those two are done. Now he has the hub, room, player, messages. I'm interested to see what config and hub are. FMT, net HTTP, he upgrades. Whoa, there's a lot more actually. But there doesn't seem to be. I think this is definitely doable. Okay. Let's continue the video and see what he does.
In Go. So to start off, I opened and use Gorilla WebSocket like it more for the process of doing than anything. But I'm going to use Gorilla WebSocket library, which at the moment is the de facto standard WebSocket implementation in Go. So to start off, I opened my favorite editor and began to work on making the canvas responsive so that game keeps resizing with the window and doesn't get blurry when user has non-standard device pixel ratio. Next, I worked on actually making the game display stuff on the canvas. Canvas provides you with a draw image function that basically copies a fragment of some image and pastes it into a specified area. So beforehand, I packed all my sprites into a single PNG file and prepared a long list of start, size, and offset values for each of them so that I can copy them out, use the offset to align them to the grid, and construct the map one element at a time, repeating this process on every frame.
Okay, so I don't remember what my offsets did. I made this part a while back. Maybe some vector. Yeah, so I don't remember what this is. Yeah, so I see. This is stuff that's still in progress, which I haven't done, which is fine. Yeah, so the offset is optional for now. So I guess we didn't even use the offset. We had start size as vector. For what, the sprite? Type sprite preset. So this is a type sprite preset, but what about sprite? Wow, okay. Does sprite preset use sprite? Yeah, it does. Okay, so players of type sprite. So if you go player here, start size and offset is not included, which is fine. So yeah, we didn't use offset, which is okay, I guess.
Next, I added the first bit of interactivity, dragging them up, which is not too complicated and involves using just a single vector for offset value. With that, some elements of the final architecture, just a single vector for offset value. With that, some elements of the final architecture started to clear out, with game state object holding all the game object information as plain data, display driver drawing them, and game instance managing it all. Lecture started to clear out, with game state object holding all the game object information as plain data, display driver drawing them, and game instance managing it all. Next piece of the puzzle will be grid component that will manipulate game objects based on user actions and server messages. After implementing dragging, I worked on zooming. The sprites. After implementing dragging, I worked on zooming. The sprites must be scaled by natural numbers to keep them pixel perfect, which means the initial zoom would give a 100% jump in size. That's why I prepared sprites in two base sizes, 64 and 96 pixels, so that by interleaving them I can obtain smoother jumps. So far, when implementing dragging and zooming, I only worked with screen coordinates. But to manipulate tanks, I need a way to translate between coordinates on the screen and coordinates on the grid. This was a little bit harder than I expected, and I was glad to come upon this nice website dedicated exclusively to hexagonal grids. With that, I was ready to begin tank navigation system. Users can perform two actions with a tank, either moving it or shooting in one of the 6 directions. Moving is carried out by pressing on the tank and dragging to a different axis, and shooting by pressing it down for a tiny bit longer and releasing on selected direction. Range of a single move will be limited to some value, so players don't traverse the whole map in one turn, and same will be for the range of a shell. After that, I started working on adding 2 more features. One is limiting players' field of view or fog of war, so that players can only see action happening inside some radius around their tanks, and the distant parts of the map are darkened out. The second feature is drawing markers indicating cells that tank is allowed to move into. With regard to the current path and obstacles, it will be actually 2 different markers, green one taking neighboring tanks into account, and the yellow one ignoring them. Both can be calculated with a simple breadth first search. Then I began working on the UI system. To display buttons on canvas on screens with different sizes and aspect ratios, I will need some substitute for CSS grid. I came up with an idea of invisible panels that will be resized and realigned on every change and will act as an intermediate grid for UI elements. They will be defined in 2 variants for vertical and horizontal screens. Implementing buttons from scratch is trickier than you might think, because in HTML DOM or UI libraries, you usually work with complete events like click or hover. But in this case, the buttons are just some painted area of canvas, so I will have to work my way up from simple primitives, pointer up, pointer down, and pointer move. And clicking a button isn't pressing the mouse on it, but rather releasing while hovering. And it's by design because it makes the action cancelable by moving the cursor out before release. It gets more complicated with both the game area and the UI. We don't want to trigger the button when we are navigating the map, and likewise, we don't want the grid to respond to our mouse drag when we interact with UI. So I added some basic in-game buttons and a main menu, in the result adding two more components to client architecture, the UI system, drawn by display driver, and the notifier that will pass button and other game events from UI and grid to game instance. Up next was finally writing some server-side code. I set up a file server to serve static files and a WebSocket endpoint. For now, I wanted the server to receive players' intended moves, resolve them, and send back the results to client. Of course, I could write my own binary message format, but I'm going to keep things simple and just use the omnipresent JSON. The WebSocket driver object on the client side will be responsible for exchanging the messages and notifying game of any updates. As you can see, the system takes collisions into account and correctly resolves them. As you can also see, the frontend is devoid of animations right now, and final result is displayed instantly on the map instead. I will tackle that later because I'm going to implement shooting first. For that, I again need to touch server-side code, add some constraints for how far can a projectile fly, check its path for any buildings and tanks, and if there are any, stop it early, and if it destroyed something, tell that to the client. What I also need is tracking each tank's visibility. Without that, everyone could have a wall hack and see all the opponent's moves on the... At this point, I was quite surprised it all works so well together, and started the hardest challenge of this project, namely the actual server-side logic for real multiplayer. Because I'm writing it in Golang, I decided to abuse channels for the player room hub communication. What I got was a pretty messy maze of channel connections where I had to track which of them guarantee reads and which do not. I added state machines to make this mess more manageable and spent some time looking for possible coroutine leaks.
Okay.
The resolution of players' actions also changed somewhat.
Okay, so I think the best way to go about this is just going file by file maybe and breaking down its functions and taking out what we need from this. Yeah, because he did touch on some things. There's also README, which could help. Okay, maybe not. Yes, okay. We have config.go. New base config, swap players. Is this for coordinates? What did the original... Where did it go? Not this. Yeah, what did this have? Because what do we need? We need rooms. I guess maybe we don't need to implement that right now. We can just... There's really only going to be 2 players, so... Maybe we don't need to do that, but it would be kind of nice, so maybe we should. We'll see.
With input from 2 players that needed handling.
I should preface, I don't know anything about Go. This is me learning WebSockets and Go at the same time. Okay. The connection type. Okay. Server application calls the upgrade method from an HTTP request handler to get a connection. So we upgrade, and we saw this, right? We saw this somewhere. Hub. Yeah. Upgrader 1024, handler. Where is that? He did in server.ws. Call the connections write and read messages methods to send and receive messages as a slice of bytes. This snippet of code shows the echo messages using these methods. I think we need to start writing. That's what I want to do. I want to just start writing. Let's do that. So I feel like hub.go is pretty important. Maybe main would be as well. Import net HTTP prof. I think the issue is that I don't know enough about what this does. So I need to learn. But he goes pretty fast in the video. But maybe we can go section by section. I think we use GPT for this one. Maybe we can decipher his code and come up with our own thing from that. While this is running, I'm gonna get a snack. I'll be back. Is it working? Oh, this is working. Let's see. Yeah, we are. Okay, I got my snack. So, what did it say? Here are the high-low tour of this, why each one matters. Oh, it actually read it. Okay. Main.go. Set up the HTTP server. Let's pull this up. This is how you learn. This is how you learn code structure, which you know nothing about. Main.go. Oh, this is not good. I'm dropping a lot of frames, it seems like. That's not good at all. Come on, pull through. Oh gosh. No. Okay, it seems like the packets are back. Okay, I'm gonna just keep talking maybe. because it seems like it's getting better. Yeah. Okay. Seems like it's better now. So we are in main.go. Entry point. Maybe I need to include that. Maybe I need to include that. So we are gonna hide this. We're gonna add something. We're gonna do main.go. Easy. No, not there. Delete that. Let's hide all of this. Hide this. And I wanna have a main.go. Okay. Starts the Go program, sets up the HTTP server. Main.go. Start the program. Okay, maybe we need the package.main. Yeah, and the what's it called? I was just dropping a bunch of packets for some reason. I think the home Wi-Fi is just not meant for, not meant for this, but it's okay. We're pulling through. Package main. Okay, so seems like we did the same thing here. Yeah, and then import FMT. What is FMT for? Formatting text, printed console, standard library packages when you install Go. Okay, we'll do that. For real, home Wi-Fi is a trooper. The dorm Wi-Fi is crazy though. That thing is really fast. Oh, not this. No. Undo. No, not undo that much. Okay, we're gonna import FMT, right? That's basic, that's a standard library. What, where did it go? Okay, I'm not using it, that's probably why. And then net HTTP, that's a new one. Maybe that is for setting up the HTTP server. That makes sense. No, okay. Net HTTP. Oh, I'm goofy. I love my Wi-Fi. No way. I'm gonna accidentally open Discord and share the video that you showed me today. On accident, of course. Import something, which we don't care about, from net HTTP prof. Okay, so I don't understand why we need this. I'm not gonna include it yet. We'll run into the error and see why. Main. Okay, the standard print line, just say hello world. Okay, I guess we don't need to do these here. New hub. Okay, so what is this? Serves the static front end in the web folder so your browser can load the game. Okay. Mounts the WebSocket's endpoints the client uses to connect. It wires it to hub and game logic. Okay. Initializes global pieces like central hub and maybe loads config. Initializes hub and maybe loads config, then listen and serve. Okay, I understand listen and serve. Initialize, what is it? Global pieces like central hub and config. Huh. New hub. So is this what is this? Is this built in? Where's this coming from? Maybe this is part of Gorilla WebSockets, right? Yeah, maybe this is part of Gorilla WebSockets. So what is this? This is for HTTP requests. That's what it is. To use pprof, link this package. This package is for the side effect of registering its HTTP handlers. You need to run an HTTP server. Then add this to your main function. I'm a little confused by this. So I know it's for HTTP requests. That's all I know right now. I think we need to go line by line and see what's going on here. Explain this name. Okay. Okay, yeah, that's simple. Okay, what is this? New hub. So this is, I'm assuming it just creates one of these as a new hub. But let's make sure. Stores return value in a variable named hub. Yes. Hub is a central message broker that tracks, yes, routines. Okay, so we're going to create a new hub. Manages multiplayer state. Okay, let's do that. Hub, new hub. And I think for this, we don't need that. Yo, what's good? What is pew pew? I'll show you. I will show you. Let me go here. What is it? Maybe I should maybe I should actually be a bit more clear in my titles. Let's show you. I need CD and disk. It's a little video game. Live server. Okay, this is what it is. So right now it's super basic. It has really basic player movements, but I want to eventually make it so that I have like a map, and I want to make a multiplayer. I don't know the full goal of this game yet. This is just for kind of for fun, but it would be kind of nice if there were two people who could play this. Maybe it's like an adventure game. Maybe it's like just a shooting game. I don't know. I just called it Pew Pew because he looks like he needs like a laser gun. You know the vibes. Are you learning Go? Yeah, I'm like, I'm learning Go while I am coding the back end of this in the structure of this. So yeah, I'm learning it at the same time. I have faith that I can do this though. So we'll see how this goes. I think I have I'm worried if there is an issue with this though, because if I click inspect, you will notice something kind of crazy. Like this thing just keeps rising. And I thought that if this rises over a certain amount, the game slows down. I don't know if this is a memory leak. Project-based learning is great. Yeah, it's definitely the way to go. I feel like just sitting and watching something is kind of tiring. I'm hoping this is not a memory leak. If it is, I may not be fully aware of that, but that's okay. So yeah, that's what it is right now. I'm watching this video by Kodistan. He made a game in Go. The game itself is very different, but he's using Gorilla WebSockets, and I need to learn how to use Gorilla WebSockets. So that's what this is. It's going to help me structure it so it is able to compile a little bit easier. But we're seeing what he's doing here. So we're making a new hub, which is what we have here. The hub will talk to the client in WebSocket. Does he have client in here? Maybe he rewrote that something else, but we have that. What else? We're going to do go hub.run. What is that? Starts the method as separate go routine. Background thread managed by go. Hub.run. Listens for register unregistered events. Okay, that makes sense. Okay, this makes sense. So this is what we were talking about earlier, where there's channels for each routine, and we're just making the routine, I think, for the read and write. I think that's what this is. Go hub.run. Okay, so we're listening for registered unregistered events. Okay. Do I know Rust? I know nothing about Rust, but it seems really interesting. I feel like Rust was a really big thing, but I don't hear about it as much anymore. What about you? Do you know Rust? Go hub.run. Oh, what am I doing? Obviously it's hub.run. We're creating a new hub, so we need to run that. That makes sense. Okay, we're gonna run the hub, and that runs this, which we need. Okay, makes sense. Then what do we have? We're creating a static HTTP directory for webdist. So I'm assuming we are going to run webdist and we're setting that equal to static. Defines the directory, yes, as a HTTP directory source. That makes sense. That's what we have here. Holds front-end assets, tells where to run. Okay, this makes sense. Static. Directory. Oh, it's HTTP directory. HTTP dot directory web dist. Yes. What else? You know what I realized? Maybe I should link our Discord. Let's do that. Studi, invite to server, edit invite link, no limit, expires after, never. There, I need to do that. Join our Discord. And then can I pin this? There you go. What else? We have this holds our front-end assets, where to serve the website and game files from. Then we have handle. For any request to the root URL, serve files from the directory, returns a handle that serves static files automatically. Okay, let's see. So if we're visiting index.html, the server reads from this. Okay. So this will actually read each file individually depending on the endpoint. Okay. Why do we do this though? Let's do a new window. Why do we do this? A folder on your system. Yes, I know what it does, but why? Every browser request gets mapped to a file. Yes. Okay, but why do we do this? Your browser must load to render your web page. Without serving them, the browser would show nothing. Okay, that makes sense. So this is in order for us to actually load the page rather than, I guess, oh, how is this different than live server? Your new video presentation was so good, especially the starting part, heading press presentation. Thank you. I was hoping that it would turn out okay. I was a bit worried because I did not edit it as much as I did with my normal videos or my shorts, so I was a bit worried that it would not look as good. But I'm glad it is. Thanks, thanks, Inexp. Appreciate it. It's very motivating. So I can make more now. I was worried it was not going to be that great. Okay, good question. They're used in different contexts. Live server is a Node.js package. Okay, for front end, for static files. Okay. So this is part of the full application, which makes sense because we're not just doing front end now. Now we have more things to work on. Okay. Video editing skills are good. I was worried about my bad. Dude, I was worried because whenever I was editing my shorts, I would spend a lot longer on them, and they they I don't know, I would just spend a lot longer on them, and I felt like they weren't as artistically done compared to, or no, they were more artistically done than this video. So I thought, like, I don't know, I was kind of surprised. Yeah, it looks good then. No, 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 no. I know Inex has a video cooking right now. It looks pretty fire. I appreciate it though. I appreciate it. Okay, let's see. Okay, this is a part of the full stack applications. Yes, because we're going to be using APIs. Not for this though. We need a visible UI and backend communications, so that's why we are using it. Makes sense. I agree. Let's keep this open actually. No. Yeah, let's keep this open for any further questions. So now we can set this up. So we're going to handle anything going to the root directory. HTTP handle. And we're going to set that up to any, what does this say? Handle registers for the registers the handler. Handle registers the handler. That's a mouthful. For the given pattern, documentation explains how patterns match. That's cool. HTTP, and then what is it? Handler function, file server. And then we're gonna just do static, because that is this. Cool, 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 cool. Now, what do we do? Handle function. Well, let's figure out what this does. So we have handle, then we have handle function. Registers a HTTP route. When a browser requests a WebSocket, run hub.serve WebSocket. Okay, and yeah, serve.websocket actually upgrades the HTTP connection to a WebSocket. So whenever we hit the endpoint dash WebSocket, we're gonna run this. Okay, let's write that in a comment. When hit end dash ws run what are we running? Hub.serve. Yeah. Okay. Now we can do this handle function. HTTP handle function? Yeah. Whoa, that's not it. HTTP handle function, capital H, handle function. Bro is always something, is doing something new every live stream. Yeah. I have an overarching Chrome extension which I'm trying to make, and all of these small little projects are all contributing to the bigger thing, because I feel like if you're just doing one big thing, you can lose motivation. So if you break it up into smaller things, it makes it a bit more fun and more entertaining. Otherwise it just gets kind of boring doing the same thing. And I feel like you learn a bit more because each use case is a little different. Oh, okay, hub.serve. So is this a built-in function for a new hub? Is it? Let's ask. Is what is it called? Is serve WS is serve is a built-in function for new hub. Do you know MERN Next.js? Yes, I do. That is actually what I use most of the time. I switched off of using MongoDB. Now I use Postgres, and then I use Express, I use React, I use Node. I haven't tried much of Next.js, although I do want to because I've heard really good things about it. I've heard bad things about Vercel, but I've heard that you can still use Next.js without using Vercel. So I do want to try that at some point. I considered using it for a Chrome extension, but the main benefits of Next.js are the fact that you have a optimization for I forgot what the name is. Whenever you're typing things in and you're searching for stuff, is optimized so that you pop up. But for a Chrome extension, you don't really need that. And of course, I think routing is a bit nicer, just set up already for you. So I didn't have much use cases for what I wanted to do, but I do want to use it at some point because it just seems really convenient. On the hub type. Okay, so he defined this on the hub type somewhere. Where do you think that is? Maybe in hub.go. Maybe it is here. Yeah, so this is how he makes, yeah, new hub, right? Is that what we just did? New hub. I think our casing might be wrong. It is wrong. Yeah, it is wrong. So we are defining the type. We're setting hub to new hub. So we are making new hub. Okay. So we're learning something from this. Vercel is for deployment. Actually, it's really good full stack framework. Yeah, it definitely is. The only thing I hate is they bring new versions of frequently so frequently, like it's nothing. Oh wow, do they change a lot for each version or what? Because I'm assuming if they deprecate things, that would be definitely annoying. But if it's just like a general upgrade, I feel like that's fine, right? Like it can't be bad. Unless you're trying to upgrade your application, which could be annoying. Because then if you don't upgrade it, then things can get deprecated, I guess. So then you don't want to run the risk, so you might as well upgrade. I can see the downsides to that, actually. They deprecate a lot. Oh, okay. Yeah, I can definitely see why that's not fun then. There's like a funny website. It's called like Days Since. This is kind of unrelated. Last JavaScript framework. Guarantee you this has 0. Yeah. Next update in about 4 hours. So we'll see. We'll see if this goes to 1, but that's crazy. Yeah, I feel like a lot of things within web development get moved on really quick, which is kind of annoying. Because if you're working in C++, then like you're pretty much set. You're not gonna really change what you're working on for a while. At least I think. Okay, hub.run. So these are all functions within this new object. So what are we at right now? I want to remove this. Okay, we're at handle function. Whenever we hit this endpoint, we're going to create the WebSocket connection. And at the end of it, we are going to just open the port and listen to the server for any requests, I think. Let's make sure that's correct. Serve and listen? What is it called? Oh, listen and serve. Listen, oh what? Listen and serve. Localhost 8000 for our backend. Yeah. Local host 8000, and then we'll do nil. For no handler. Oh, that's not correct. Okay. Undefined new hub, because we did not make that object or method yet. Compiler undefined. Print line, right? Okay, we're correct. Undefined new hub. So we'll make that next. We will make that next. Now that we made that, I'm kind of curious. I think the front end will still work. I have no reason to believe that it won't. But let's just try it. Yeah, it still works. This is so responsive. I don't know. I'm like really happy with how this character is. I don't know how to zoom in, but very happy with this. Drop ideas for game ideas. I think this could be cool. Right now, I'm feeling either a shooter game or an adventure game. I want it to be fun. I want it to be interactive. That's a big thing. It has to be interactive. Yeah, a shooter game would be easy. It needs to be multiplayer too. We'll see. We'll see. This will take some time, but I want to learn WebSockets. That's the goal with this, more than the game. For existing project, you have to run one command to update it to the latest version. But the problem is, if you're learning Next.js from YouTube, the different version makes it hard to follow. Oh, yeah, I've definitely experienced that before as well. Whenever I'm working with, I think it might have been Go. It might have been Next.js. I was following a tutorial, and they were using an older version, and it made it very hard to follow along because things were like all outdated. And so you want to have things which are kind of new and updated, because if you're learning something that's old, that doesn't really benefit you because it's already outdated. So it definitely is annoying to have. It's definitely annoying to follow these tutorials, but it's also this weird area where like following documentation is really nice and it's ideal because it's really updated, but it can be hard to follow that, especially if you're new to something. Like learning WebSockets purely from documentation, I feel like it's kind of tricky because I know nothing about it. So I would prefer a video. But videos just don't have that much. Only so many people can make a video, you know? But there's so many more people who can write things. So I've been trying to switch over to just learning from documentation. That's why I'm using this, like GPT. Like I'm not using it to create knowledge, more so to clarify existing knowledge. So I gave it this knowledge, which is from a person, which I is far more accurate. And I'm just clarifying. So it's like, it's weird. But the good thing now, they have the instruction mentions the version they're using and shows his package files to change the specific version he is using. Oh, that's nice. Yeah, that's definitely much clearer. Wait, did you change your username? I just realized. Did you change your username? That's funny. I like it. This is very nice, very clean. No, this is not built in. Yeah, wait, what? This is the second one. Oh wait, well, let's read this though. It's not a function that your project defined on. Typically something like this, yeah, we did define it, or we will define it. Endpoint for WebSocket request. It'll run whenever it's trying to open a WebSocket to actually upgrade the Okay. Okay. It should be working now. That was a good call out. I would not have noticed that. I don't know how much I was talking whenever it cut out. My microphone died, or the receiver died. That would be a good time to check my battery levels. I'm using this thing right now because my actual mic is in my apartment, and I'm not there yet. So this is the solution right now. I'm using this little DJI mic. But yeah, thank you for the heads up. I would not have known that. Maybe I need to add that to my waybar, like a icon that says if my audio is out or not. That would maybe be useful. Okay, maybe that's something for next stream. Change it up every stream, right? Okay. Yeah, so I'm unfamiliar with what this is. Audio's back now? Okay, good. I'm unfamiliar with what this is. I think it's a pointer, but in C++, the pointer is flipped, I believe. Maybe I'm missing something, but we'll figure out what that is. Right now we're just going over what serve.ws should do. And whenever we actually write it, we will make sure that is correct. Okay, so we are going to launch Go routines to handle messages, read and write pump, client dot. That makes sense because we need the client to read whenever we're receiving stuff from the WebSocket and write when it's going from the hub to the WebSocket. Do you guys like my drawing? I feel like it's very, very nice. This is also the game structure, which we'll be using, we are currently using. Move that back down. Okay. Okay. Now that we've done that, let's do that. Okay. Serve.ws is a custom glue function, accept, upgrade, add player, start, rise it on hub. Hub manages all connected players, so WebSocket should be a method for the hub. The hub needs to track clients, broadcast messages, remove clients, and it makes sense that this connects a browser WebSocket into the hub system. Okay. And of course we created the hub using new hub. Got it. So now I think we need to create the new hub. I feel like that's the next logical step. So let's go through and let's see what the next step is. Yeah. Listen and serve starts an HTTPS server on port 8000. Nil means the default HTTPS MUX, the thing that routes request. Use a default HTTP route. What is MUX? I've never heard of that. HTTP MUX. Bro, how about making multiplayer Flappy Bird game? That seems fun. The only thing is I've already started this. I feel like this is a bit more unique than Flappy Bird. I feel like Flappy Bird is kind of like it's been done so many times, you know? But I feel like this has like a potential to be something more unique and have its own impact. Because Flappy Bird's already been done. And particularly isn't too interesting for me, but I think it's a pretty decent idea. HTTP request multiplexer. Okay. The component and web server is responsible for routing incoming HTTP requests to the appropriate handler. Routing incoming HTTP requests to the appropriate handler based on definition rules. HTTP multiplexer. Use the default multiplexer. This is not the multiplexer. Let's read. Yeah, the default multiplexer is configured by the earlier handle calls. Okay. Use default multiplexer since we defined it in earlier handle call. Okay, nice. There we go. Important. This line starts the entire server and starts the entire server and blocks forever while it runs. Okay. Okay. So we're going to show the server starting, create the hub, run the hub. We're setting the routing for it. And what is this? Oh, we're going to upgrade the WebSocket, upgrade to WebSocket. Whenever this server sends a /WS request, we're going to upgrade the WebSocket. And then we're going to open a port on localhost 8000. Right? Yes. Now that we've done that, config.go is the next thing, but I think we need to do hub.go. Let's see what config.go is, and we'll see if we want to do this or hub. Vector.go, player.go, room.go, game state, messages, hub. We're gonna do hub. Okay, so let's go to hub. Hub.go. Plain each. Do the same for this hub.go file. And then let's read what hub.go is from a high-level overview. We did not incorporate this, so maybe we will need to. But we didn't run into any issues, so I don't want to. Because I want to figure out why we can't include it, or why we need to include it. So, hub.go, something we need to add. Maybe we should upload this though. Yeah, let's push this. So okay, so it is multi-class. Okay, so I need to do git add dot slash. So should we push often to git commit? No. What are we going to do with this? Well, what we did is we set up basic go. Let's just do setup main.go. There we go. Yeah. Okay. Do you like my ASCII art? I feel like this looks so cool. So with hub.go, we are going to have package main from main. Yeah. Why do we do package main actually? We use it when you build an executable program, not a usable library. Will run as a standalone program. If you compile it, it creates a binary app you can run. Okay. So this Go will not really compile it into a runnable app unless some other file has package main. Okay. So I guess this just makes our program runnable. Okay. I guess that can be simple. Central WebSocket Hub slash Orchestrator. What it very likely does. Maintains a registry of connected rooms, players, registering, unregistering players, a broadcast channel for messages, has a run go routine that listens on these channels, dispatches incoming messages to the appropriate room or handler. Dispatches appropriate message or incoming messages to the appropriate room or handler. Okay. Manages concurrency so multiple players dash rooms can be active safely. Why is this important? Acts as a concurrency traffic controller for the entire game server. Separates low-level WebSocket plumbing from game logic. Hub cares about connections, routing, and fan-out. Room / game state care about rules. Okay. If you ever scale up, the hub is where you'll plug that in. Okay. So that's what hub.go is, and now I think we already asked it to clarify these line by line breakdown. Hub.go explain line by line. So we import main, handle HTTP requests, and Gorilla WebSockets. Sorry, that import fmt net dash HTTP, and then we're going to do gorilla.com dash WebSocket. Right. Yep. We'll probably be using this in serve WebSocket. Variable upgrader. We're going to create a. Wait, make sure audio is back. Yeah, audio is still there. It looks like our packages are pretty good. Or our packets. Pretty good. I was just making sure. So, let's see. Maybe 30 minutes. Okay. We're going to create an upgrader to upgrade a WebSocket. Buffer sizes affect how much data can be read or written at once. This does not override check origin, meaning default security rules still apply. This could matter later if hosting online. The object performs a handshake that transforms into a person. How much can be read at once? No, I'm not fully understanding this. We have an upgrader, WebSocket.upgrader. So I guess it's how much data we are upgrading. Well, we'll put that now. WebSocket.upgrader, and we're going to treat that as an object. Read buffer size of 1024 and a write buffer size of 1024. Yes. Now represents a message sent to the hub requesting a room action, which room and communication channels to interact with the room. So which room and the channel for the room. Okay. This is type. So this is type room request. We'll do the full thing, room request. Structure containing, what is it? Code, the room code as a string, as well as, what? Okay, as well as, so that's the channels, communication channels. So room channels. Got it. Okay, what else? We're doing hub.code now. Well, we're doing another struct called hub. The hub owns channel of room requests, meaning that, okay, the hub owns room requests, and the room request has its own things that it requires. But the hub is defining the room request as a channel. So the hub structure has a room request channel called room request. Why is room request and room request? This, it might just be a types thing. This is a struct. A variable that holds a type. So I'm assuming we would, so we are setting room request to have type room request. Yeah, that's what I said. Okay, it's a channel. The hub owns a channel of room requests. Okay. Create room. Okay, there we go. So do type hub. Room requests. Nope, that needs to be. There we go. Room request is now, okay, room request is now a channel of type room request. I feel this needs to be better defined. Room request type. Okay, now that that's done, we'll do hub type. But did we write anything using hub here? New hub. I think it should be fine. Okay. The hub constructor, correct to the correct room. Hub constructor. So how we're going to make a new hub? Well, we're going to do a function called new hub. What is this doing? Returns a new hub containing a fresh channel. So we're returning a new hub containing a fresh channel for requests. And it looks like we're using pointers here, so I want to clarify that. What does the and this code pointer to a hub, we're gonna returns a pointer to a hub, and then yeah, we're returning. Wait. We're returning the address of it. Okay, I'm a little confused because if we're returning a pointer, why are we returning its address? If we are returning a pointer is a value that stores an address in some data, right? Okay. Oh wow, this is getting weird. We're creating a value of type pointer to hub by giving the address in use function. Okay. This function returns a pointer to a hub. And the hub has an address. So we're returning the address. No, we're returning the pointer, but we're returning the address. Getting a little confused. I think my brain is getting tired. The type of value that stores addresses of houses. So we do we're returning the address, and the address is the pointer. So if we're returning something, we don't want to return a pointer. We're returning the address. We're returning the address. If we are returning the address, why don't we write start in the expected type? One is the type and one is the operator. So it's the type. Oh. So there's type and then there's a value. Return type pointer when making new hub. So we're going to return type hub. Return that is type, and this is a value, it should be. Okay, let's do star is operator. Creating return values or pointer variables, address of this hub value. Let's do value actually. Star is type, star is. Yeah, I know that this dereferences the hub. So are we? Well, we'll return the address and it's expecting a pointer. This is a little confusing, but maybe this will make sense the more exposure I have to this. Variable type, here's the actual address itself. Let's type. Start hub. Okay, let's go into this. This returns a new hub containing fresh channel for room requests. A new hub, make a channel I thought this was for the room request. Hold on. This becomes a value inside of the structure field room request. Room request is a channel whose element type is room request. It's capital room request. Okay, so I'm confused as to why we're not using this. This is a type. Also a type. That's the variable itself. So why are we making room requests other than room requests, since room request is the type? Create a channel whose elements are of type room requests. Oh, okay. Create channel in hub of type room request. Yes. That star hub. Okay. Returns a new hub containing a fresh channel, right? A new hub containing a fresh channel of type room requests. Yes. No rooms exist yet, but they will be created when first requested. And then there's the actual main loop. Can we get rid of these for now? Is that a thing? Oh, it is a thing. What'd I do? Oh, it's just a spacing issue? Okay. Okay, my brain is getting a little tired, so I'm going to stop it here. We're going to stop it here. Where are we at? So we needed to do the main game loop, and then, or the main hub loop, and then the actual server WebSocket writer. And then I think after that, after that we'll see where we go. Okay, I'm going to call it here. I feel pretty good about this. I'm getting tired. My brain is kind of tired though. So, thank you guys for watching. I'll be back. We're going to continue this WebSocket adventure. But yes. Okay.